Okay, so 2.2 is going to be really similar to 2.1. We're going to be looking at analyzing linear functions. More specific to this one, or this lesson, we're going to be talking about solutions and 3 ways we can get them. So we're going to talk about creating a table, graphing, and then solving the expression, which is very similar to what we did in class yesterday and on the last video. So first thing, if we start with a problem situation, so we've got one right here. A hot air balloon is floating at 1,000 feet, and it begins to ascend, which again means to rise or go up at a rate of 200 feet per minute. So there's 3 ways we can evaluate this. We're going to look at a table, we're going to look at a graph, and then we're going to look at an expression or an equation, really. And we're going to think about this if we want to know how high we are after 5.2 seconds. Okay, so first thing we're going to do is our independent and dependent quantities. So we know that we're going to have time and height for our independent and dependent quantities. We're measuring time using minutes, and we're measuring height using feet. Okay, so we talked yesterday in the last lesson about how to fill out a table. In this case, I'm going to jump to our expression first. We're going to use t as our variable, and since we started at 1,000 feet and we're rising at 200 feet per minute, it's going to be 200t plus 1,000. Okay, our initial value plus how fast we're rising. So at 0 minutes, we would have 1,000 feet. At 2 minutes, we'd be at 1,400. At 4, we'd be at 1,800. And then at 2,200 feet, we'd have to work backwards. So you'd actually subtract 1,000, then divide by 200, and that would be for both of these. And so then at 2,600 feet, we will have 8 seconds. Right, so that's how we would fill out a table. Now, if we wanted to know when t was 5.2, meaning we are looking for h of 5.2. The problem is, you see on this given table, we don't have 5.2. We know it's in here somewhere because 5.2 is in between 4 and 6, but that only tells us that we are about 2,000. Okay, and I come up with the number 2,000 because since 5.2 is between 4 and 6, that tells me that in between 1,800 and 2,200, right in the middle is 2,000. So we got to be pretty close to that. But again, this is not exact, which kind of creates a weakness there for our table unless we have exact values. Okay, another way to look at this would be to graph. So if I'm going to start my graph, I'm going to label my x and then my y-axis. And I know since I had seconds all the way up to 8, I'm going to count by 2s and label these 2, 4, 6, 8, and 10. On my altitude, I think my highest was 2,600, so I'm going to count by 500s and go all the way up to 3,000. So my first point would be at 0, and my initial value is 1,000, so I'm going to put a point at 0, 1,000. And then it was at 2 and 1,400, and then 4 and 1,800. And I believe it was 6, 2,200, and finally 8 was at 2,600. And I can draw that and then go ahead and create a line, and hopefully if we drew them pretty close, we're right about on that line. So maybe the 8 should be up a little higher right there. Okay, so that would give us our line. Now again, we want to know where we're at 5.2 seconds. So if I take and I create a line, let's say we know 5 is in between 4 and 6, so 5.2 is going to be right about here. That's going to tell me my point would be right on this line. So we would want to know what we're in between. And it looks like now we're just above 2,000, so maybe 5.2, 2,100. But again, this only gives us an approximation. It doesn't give us an exact value, at least not with having a definite point on the graph. Okay? So both the table and the graph gave us an approximate value. Something that will give us an exact value will be an expression, or even better, an equation. Okay, so our expression we already said was 2t plus 1,000, which tells us our equation, f of x equals 200t plus 1,000. So the only thing, we should actually have a t here, and we can call this f of t, or I believe I called it earlier h of t. We can use this where x, or I should say again, t is our value for seconds, and h of t is a value for height. So if I tell you that t is 5.2 seconds, then in order to find my height, I'm just looking for h of 5.2, which means I can plug in 200 times 5.2 plus 1,000. And if I plug that into a calculator, I would get 2,040. So you see, both those other approximations were close, but they were not exact. Okay, another way we could do this, suppose I asked you, when is the balloon at, let's say, 250 feet? Which means now we are given a value for h of t. So we're going to take our equation, h of t equals 200t plus 1,000, and we need to work backwards this time, okay, because this height is the value for h of t, which means we're going to replace this piece. So 250 equals 200t plus 1,000. Okay, and we're going to start by subtracting 1,000 from both sides, which would tell us that negative 750 equals 200t. And then we are going to divide by 200, and that tells us that t is equal to negative 3.75. And remember, this is a value for time, so that's negative 3.75 minutes. Also remember that when we talk about negative time, this was in the past, or you could think of this as 3.75 minutes ago, which makes sense because right now we're at 1,000 feet, and I'm asking you, when were we at 250 feet, which means it should have been in the past because we are rising. Okay, so in this problem situation, we are able to use negative time because it just tells us where we were in the past. Then tomorrow, again, we'll kind of do the similar thing that we were doing last session in class, or next time we see each other. We're going to identify the independent and dependent quantities. We still need to kind of practice that. Then we're going to practice solving through our three methods. And finally, identify the strength and weaknesses of each. All right, we'll see you next section.